What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Okay, I'm not sure if I got that one. What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today we're going to go over, we're actually just going to upsolve. We're going to upsolve AtCoder contest 174 logs, E-logs. Okay, so we have N logs of length A1, A2 to AN, and we need to cut these logs at most K times in total. When a log of length L is cut at a point, the distance from the log is 0. Distance from an end of the log is between 0 and L. Okay, so if it's cut between a point, the distance is between that 0 and L. It becomes two logs of length T and then L minus T. We need to find the shortest possible length of the longest log after K cuts. Shortest possible length of the longest log after K cuts. Okay. So first of all, let's just read in N and K. So let's do that first. Let's get rid of this. So we're gonna read in N and then we're gonna read in K. So we have N here, and then we have K. So we're gonna read in N, K, and then we're gonna read in all the values of A. Okay, so then like that, and we're gonna go on 3 from the beginning, and then read in A. Okay, so now we need to cut these logs at most K times in total. At most K times in total. So it's not the smallest possible cut. So the maximum we could cut is K times. So we could loop. Okay, so we might need to start from 0 to K sometimes. Okay, we need to cut a log at a certain point and it becomes two logs, T and then L minus T. We need to find the shortest possible length of the log after K cuts. So if we cut every single log, okay, so let's look at this. So we have 2 and 3. We could have at most 3 cuts. And we have 7 and 9. So 7 and 9 are the two lengths of two logs, right? When a log is length L, okay, yeah. So 7 and 9 are, I think it's the length of the log. Let's see. N logs length, yeah. So 7 and 9 are length of the log. Okay, so first we could cut the length of 7 at a point whose distance is 3.5. So it results in 3.5 each. So then that'll be 3.5 for both of the 7s, okay? Next we could cut length 9 at a distance of length 3. So then we could have 3 and 6, okay? Last we can cut the length of 6 at a point whose distance from the end of the log is 3.3, resulting in 3.3 and 2.7. The longest length of the log will be 3.5, which is the shortest possible result. Rounding it up, we will be 3.4. Okay, so wait a minute. Why is the longest log 3.5? Can I just cut it in half every time? Let's go back up. We need to find the shortest possible length of the longest log. Shortest possible length of the longest after K cuts. Shortest length of the longest log after K cuts. So if I cut the log, so let's say if I cut the log at most K cuts. So the shortest possible length of a log. Of the longest log. The shortest possible length of the longest log. Isn't that like an oxymoron? Find the shortest length of the longest log. Okay, so the 3.5 shortest length is 3.5. Output should be 4. I don't really understand what they're saying. Shortest possible length of the longest log. What does that mean? If we cut the lengths at most K, when a log of length L is cut a point, yeah, it becomes two logs, L, T, and L minus T. Yeah, I understand that. We want to find the shortest possible length of the longest log. The shortest possible length of the longest log. So after you cut a log, it's going to be the longest log. We want to find the shortest length of the longest log. So the longest log, so okay, in this case the longest log is 9. Shortest length, why would it be 4? That's a big if. Why is the shortest length 4? See, this is a thing that I don't really understand some of these questions. I don't understand. Let's see live chat. Not sure if anyone's watching actually. Probably no one's watching at this point. Cause it's late at night. I have not actually been live streaming at a decent time. So from now on, I'm gonna try to live stream in the morning, which is like 9 a.m. Eastern. I think that'll be probably the best time to live stream. Yeah. But that is what it is. I don't think no one's watching right now. It's okay. It's okay, guys. It's okay. Let's see. 7, 4. So how are we gonna cut this at the longest length? So we have 2 and 3, and we want to cut 7 and 9. So if we're gonna cut, so we have 7 and 9. We cut 1 from 3. I'm still trying to figure out the problem. Let's look at the second case. Oh, they don't tell you the second case. So you have 2 and 3. Okay, I'm gonna get a sheet of paper. So we have 7 and 9. So we have 7 and 9. If we at one point we could cut the distance of the log 3.5, so it has 3.5 each. Okay. Now we could cut the length of 9 at a point whose distance of the end log is 3, so we end up with 3 and 6. Lastly, we would cut the length of log 6 at a point whose distance has 3.3 and 3.7. So we have 1, 2, 3.3 and 3.7. Okay, so we cut the 6 into 3.3 and 3.7. So that gives us 1, 2, 3 cuts. Why didn't we cut another time? Okay, so I don't understand the question. If we cut at a point, first we cut 7 at a point, which is 3.5. Okay, that makes sense. We cut 9 at a point whose distance from the end of the log is 3, which is that it gives us 3 and 6. Last we cut the log of length 6 at a point from whose distance from the end log is 3.3. Okay, so the maximum length of the shortest log. The longest length of a log is 3.5, which is the shortest possible result. Find the shortest possible length of the longest log. Of the longest log after k cuts. I don't know. I'm not sure. I feel like if you cut, let me think, guys. Let's see. Okay, so, because if we cut, let's think, if we cut at most k times in total, when a log of length kl is cut at a point whose distance from end of the log is t, becomes 2 lengths of t and l minus t. Find the shortest possible length of longest log after k cuts. K cuts. What do you guys think? Anyone in the chat? Anyone? Okay, it's just me. Okay, k cuts. At most k cuts. If we cut k cuts, what if we were to cut, find the shortest possible length of the longest log. Shortest possible length of the longest log. What if we just cut in half every time? Right, so if we have like 3.5 and we cut 7, we cut in half 3.5. Then 9 we cut another half 4.5. 4.5 we cut another half 2.5. Wait, 4.5. 2.25, I think. Then we have 2.25, 2.25, 4.5, 3.5. That'd be 4 cuts. Why? Longest length of a log would be 3.5, which is the shortest possible result. Okay, let's think. We cut these logs at most k in total. When a log of L is cut at a point, it becomes 2 logs, t and L minus t. Find the shortest possible length of the longest log after at most k cuts. Shortest possible length of the longest log after k cuts. I'm just a little bit confused. What does that mean? Shortest possible length. What is the shortest length after I cut k times? Is that what they mean? Of the longest log. So if I cut first, we would cut the log of length 7 at a point whose distance from the end is 3.5. Then you have 3.5, 3.5. Next, we will cut the log of length 9 at a point whose distance from an end of the log is 3, resulting in 3 and 6. Lastly, we'll cut the log of length 6 at a point whose distance from the end of the log is 3.3, giving us 3.3 and 2.7. What if we cut at the beginning first in half, then we start decreasing down from that half point for every log that we're cutting? So like if I cut at 7, I cut divided by 2, I'll get 3.5. Then we round downwards. For 9, we cut at 3. Then we have 3 and 6. At 6, we're going to cut 3.5 minus 1, up minus 0.1 minus 0.2. That gives us 3.3. Then we cut 3.3 and 2.7. Will that work? I don't know. We could try it. I'm like all out of options right now because I don't really know what they mean. Because if I cut, is there an algorithm called rod cutting? I think. I'm not sure. Not sure at all. There might be an algorithm called rod cutting. Anyone in the chat right now? You could just anyone of you guys want to give me a hint? Anyone right now? Maybe I should. I'm not sure if I should look at the editorial. Because if I'm cutting a t, okay, so if I cut t and cut t minus. Thanks, sir. Thank you. Thank you so much. I'm trying to hustle. I'm trying to do better at these. Really trying to do better at these. But it's so difficult. You know, these questions are so difficult. You know what I mean? I mean, it's like, So if I cut t, I first cut t, then I gotta cut L minus t. But then, like if I cut t, how do you get the shortest length of the longest log after k cuts? That's a big question. Because if I cut, what does that mean? Because if I cut, what if I just cut every time? So like I do, I don't know. So the shortest length. So shortest length, let's put 0. Longest log equals 0. Okay, let's do that. Let's start that first. Let's do like a over 2. So then we set shortest length is going to equal to this. Longest log is going to equal to I. I don't know, max of I and longest log. Is that what they? I don't think this is gonna work out actually. Longest log. Why can't I do this? Oh, it's an integer. Max. I have no clue what I'm doing. Absolutely no idea. Okay, if I still don't know, I think I'm just gonna look at the editorial, because at this point I don't know what they mean by shortest length of longest log. That's okay. No, it's okay. I don't really know what I'm doing at this point. You know, you don't have to. These live streams are to have a conversation with the subscribers. You know, that's the point. You know what I mean? I struggle a lot with these problems. I don't even know what I'm doing half the time. But yeah, I don't know. Maybe I see. Oh, thanks for Shav, but I might actually start like redo another algorithm series, because like I feel like I wasn't actually teaching you guys that well. So I might actually like do I want to do like a series on like competitive programming and common algorithms. I might start doing that. I might start with number theory first, because that's probably the easiest. So yeah, I'm probably gonna redo most of the algorithms. But yeah. Back to this. Let's see. We can cut logs to bars. There's actually an algorithm called rod cutting. I'm not so sure if you guys know. I'm not sure if this is what they want us to do. Because there is a problem like this. We cut a rod in multiple times. But they want, this is like, they want to find the maximum number of pieces, I think. Right, and that's different from what here they were trying to ask. Because this one, they want to ask us the shortest possible length of the longest log. So yeah, this one is determine maximum value of cutting it. So that's not the same, but I don't know. All right, dude. It's okay. You could go. It's all right. This is a bad time to live stream. What is the best time to live stream for you guys, by the way? You guys will all live in India, right? Is it like 12 p.m., 1 p.m.? What's the best time to live stream for you guys? You know? Maybe I'll put a poll. About that. All right, guys. How long have I been live streaming? All right, I've been live streaming for 18 minutes, so I might actually just look at the editorial, because I don't know what they mean by this. How do I translate this? I gotta translate this. Google Translate. Is the answer less than or equal to x? Consider the problem. In other words, this problem can be cut within k times. Can all logs be less than or equal to x in length? It becomes a problem. Consider circle of beginning the length ai. ai over x minus 1. It is necessary to cut once. This is the answer. This number of times. The answer is yes if the total is less than or equal to k. Otherwise, it's no. Is the answer less than or equal to x? Use binary search. Smallest number x for which the answer is yes. Just output the number. The calculation is n log max of a. Huh, what? I gotta read this again. Is the answer less than or equal to x? Consider the problem. In other words, this problem can be cut within k times. Yes, that's the point. Can all logs be less than or equal to x in length? Huh. So use binary search to cut. Okay, wait, hold up. I'm starting to get something. Use binary search to cut. Can all logs be less than or equal to x in length? So can all logs be less than, so let's start here. Can all logs be less than or equal to 3.5 in length? Yes. So it cuts 3.5 there. 3.5, no, that doesn't make any sense. Hold up. Can all logs be less than or equal to x in length? It becomes a problem. Circle the beginning length of AI. AI divided by x minus 1. It is necessary to cut once. And this is a number of times. This is the number of times. The answer is yes if the total is less than or equal to k. Otherwise, it's no. Is the answer less than or equal to x using binary search? Amount of calculations is n log max of a. I don't understand. What does that mean? Okay, we still can't. Okay. Consider the problem. In other words, this problem can be cut within k times. Can all logs be less than or equal to x in length? Can all logs be less than or equal to x in length? Okay, so let's take a of I and cut it in half. So let's start at it becomes a of I over x minus 1. It is necessary to cut once. This number of times, the answer is yes if the total is less than or equal to k. Otherwise, no. Is the answer less than or equal to x using binary search? The smallest number for which this would work is yes. Just output an answer. Thanks. Does any of you guys understand this editorial? So use binary. So okay. So they're gonna ask. So pick a number. Use binary search. Cut it. Is the problem? Can all logs be less than or equal to x? If it is, we're gonna increase by 1/2. We go to the top. If not, we go to the other part. We go below. Is the answer less than or equal to x? The smallest x for which the answer to the question, yes, just output it. I'm still trying to think how you would do this. Because if you... Does that mean start from get the largest value first? Because if you're going to use binary search, it's going to be... The number you're cutting would have to be between all of them? I'm not sure. Maybe I should a of I over x minus 1. Because if you're cutting half of the, let's think. We got to keep thinking. Think. At most k cuts. Then after that we round up an integer. How long has it been live streaming? All right, we're 25 minutes in. At this point, we should just look at look at someone else's solution. anytime you're, anytime you don't understand, like, if you work more than half an hour on a problem, I think you should just look at the solution at this point. All right, let's see. What did they do? Okay. So we had to get the maximum number. Yes, that I understand. So let's actually get the maximum number first. Okay, so we had to get the maximum because we're gonna use binary search, so we have to get the maximum number. So that's what they did here. So let's do that. Okay, now we start at the 0 and then maximum number. Okay, then. Oh, this is a function. Oh, this is a Lambda function. Oh, maybe I should go over a tutorial. Give a tutorial on Lambda functions because this is fun. Okay. So what they're doing is they're starting at now. They're starting at 0, and they're looping from 0 to n. And they're going to add all the numbers from a of I minus 1 over x. Was that what the editorial was saying? Circle the beginning length of a I. It is necessary to cut it once. This is the number of times. I don't understand. Okay, so this is using binary search. Okay, so let's rewrite this. Okay, let's create it. Okay, we'll create another function of what they're doing. Okay, here it's a boolean and it takes in an integer. So let's do boolean less than or equal to k. Pause. X. We should pass in k also. We should make the vector a global variable so I don't have to deal with passing the value. So let's do a, that's the vector. And here I'm going to do a is equal to vector this. So then now we have a global variable so we don't have to pass it in. Okay, so now we have that. Once we have that, now we're going to go do this. Loop from 0 to n. So n is the size. Let's do n is equal to a dot size. Let's do that. So then we don't have to do that overthink. Okay. Then what do they say? Add up a of I minus 1 over x. Why? Why? Okay, let's do that. I'm gonna give a better explanation after when I understand this. Return if your final answer is between k is less than k. So, oh, okay, I think I get it. I get it. So what we're basically doing is that we're picking a number that we're doing, right? We're picking a random number, x. We're going to cut every single rod inside our array by x. So minus 1 is just for the lower bound, right? But ideally what we're doing is we're cutting every single rod by x. That's what we're doing. Then we're summing up those rods that we just cut. if the number of rods we just cut, oh no, if the length of the rods that we just cut is less than or equal to k, we return true. So that's what this is for. So this is checking cut less k. All right, here so this is checking if all cuts are less than k. All the cuts that we just cut from x are less than or equal to k. That's what it's doing. So yeah, so you're picking a random number x, and then you're cutting x for all the rods inside the array. Then you sum up all the ones that you just cut. That's what this is doing. That's what the now and this is doing. Then once you sum them all up, you return if it's less than or equal to k. So that's what that's doing. Now let's look at this. So now we are going to start out with, this is binary search now. Okay. So we're gonna use binary search at this point. So we're gonna do left is equal to 0, right is going to equal the maximum number. And what are we gonna do? Basically, while left is less than right, we're going to find the middle number. So we're going to do L plus R, then divide by 2. So we're picking random numbers right now, using binary search to pick random numbers between the values. If it is check all possible, you cut the random number by that possible number, then we set right to equal to it. Otherwise, we set left equal to the middle. Okay, so if we do, I don't know why I do L plus 1 here, but if check all cut less than k, pass in x and then k, pass in mid and then k. Where's k? Oh, uppercase k. Then we set the right value to equal to mid. Otherwise, we set the left to equal to. So here, I'll use actual variable names. Left, right. Left, right plus 1. Then left is going to equal to minimum. Okay. After that, we're just going to print out right. So let's see. Okay, so let's think about this. Let's think what it's doing. Okay, so we'll actually break through here to understand what we're actually doing. So let's actually let's actually go in here and try to debug this. Otherwise we're not really understanding what we're doing. So let's go back to the tasks. So 7 through 3, 7, 9. Okay, so let's redo this. Okay, so originally our left is going to be 0 because that's the starting number we're having. Our right is going to be the maximum number. Then we're going to use binary search to pick the values that we're going to cut. The current length we're going to cut for each of the rods. That's what we're doing. Okay. Because the smallest number that we're going to cut is actually going to be between the smallest number rod and between 0 and the largest rod, right? The largest length of the rod. That's why we use binary search. So we're going to pick the middle value every single time. And if it works, then we go to the right. If it's not, we go to left, right? So that's what we're doing. And then we sum up every single rod that we just cut, see if it's less than or equal to k, the number of times we're cutting. And then, yeah. Wait, is k the length of we're cutting, or you can cut these rods at most k times, 2k times. Okay. Okay, so that's what we're doing. Okay, so let's see what we're doing. So this is good. It's gonna get the minimum values, which is 4.5. or 4, we're gonna check, can we cut all the values of the rod less than or equal to k? So we are going to, for every number, we're gonna divide the number by 4. I think that's what they're doing. So so now we're gonna, we're gonna divide every single number, every rod length in our array by 4, and then we are going to sum those up. So what's our first number? First number is 7 and 4, right? So we're going to divide 7 by 4 and sum that up. So 7 divided by 4, 7 minus 1, 6 over 4 is going to be 1. And then we're going to sum up 9 divided by 4, which is 9 divided by 4 is 2, I think, something like that. So it'll be 3. I think now it'll be 3. Yeah, now it's 3. And it's done. What is k? K is 3, so this is true, so it's going to be true. So because it's true, we could cut all the values of 4, right? Cut all the values of length 4. We're going to move the right length down to the middle now, because we want the smallest value that we could cut for every length. Right. Yeah, that's what we want. So we're going to move the right down. So now the right is 4. And then we're going to sum 0, 4. So the mid is going to be 2. So now that the range that we're cutting is now 0 to 4, right? Because we want the smallest number that we could cut for each of them to have the largest value. So now it's 0 to 4. Now we add all them up and divide by 2. So that's 2. Now we're going to cut all the values in our array by 2 and then sum those up to see if it's still less than or equal to k. So yeah, 7 cut by 2 is going to give us 3. Yeah, so now it's 3. 9 divided by 2 is going to give us 4. So 3 plus 4 is going to be 7. So yeah, so that's 7. K, we are only cutting 3 times, right? So we're only cutting 3 times, so we can't actually use length 2 to cut it, because if we cut length 2 for all the rods, the final lengths are not in the range less than or equal to k. That's why. So yeah, we do that. Then our left is going to be 2. So because 2 didn't work, right, we're going to move our left up. So instead of 0, it's going to be 2 now. So now we have 2 and 4. So it's going to be between those values. So 6 over 2 is going to be 3. And we got to check 3. So we're going to cut all the rods by 3 and sum them up. So 7 divided by 3 is going to be about 2. 9 divided by 3 is 3, 9 is 9. So it's 2 plus 3 is going to be 5. Or 4, my bad. 4, okay, the lower bound. Then we check, is 4 less than or equal to k? So our k is 3, so we're only cutting 3 times, so that's false, no. So then our left is now going to be 3. And because our left is now 3, we just have right 4. Okay. I think I sort of understand it a bit, because we're cutting each rod by, we're picking a number between the range to cut. And what we're trying to do is we're trying to find can we cut all the values less than k. So k is the number of times we could cut the value. Yeah. So if we could, then we move our binary search of the right up 1. If we can't, we move left up. So yeah, I'm going to submit this now, and then I think I'll be on my way. I think it's been a pretty long live stream. But yeah, hope you guys enjoy this video. I'm going to give I'm going to give a big explanation to these problems soon after I solve E and F. So yeah, that's this live stream. I hope you guys enjoy this live stream. Rate, comment, subscribe. I'll check you guys later. What editor do I use? So for editor, I use Visual Studio. That's what I use for Visual Studio. You could use like other editors. You could use like Sublime, Vim, as long as you're able to compile your code. But yeah, rate, comment, subscribe. I'll